Hello viewers, welcome back to my channel. In my previous video, I released a video on qualitative analysis, which I told you that this video is going to be in series, and the first series was identification of a chemical substances in qualitative analysis using solubility in water. Altogether, for those of you that are new to my channel, that you've not seen the video on this, there will be a link in the description box below that will be taking you to that video so that you can watch and you can follow us with this series that is here. In today's video, I'll be explaining to you how to identify based on use of litmus paper. As you also know that litmus paper can be used to detect if a solution, altogether, if an aqueous solution or a gas is acidic or basic or neutral. That is the function of a litmus paper. Now, normally, litmus paper is used to test for the presence of hydrogen ion or hydrozonium ion in a solution, or the presence of OH minus, which is hydroxyl ion in a solution or in wet gases. Altogether, now in today's, I'm going to be explaining to you how we can do about this. Take a look on this, that hydrogen ion or hydrozonium ion, it always gives a red solution. Hydrogen ion or hydrozonium ion will never react with what? Red. Simply means it does not give any reaction with a red litmus paper, that is for hydrogen ion, but it tends to turn a blue litmus paper into red. But when you react hydrogen ion or hydrozonium ion with a red litmus paper, it shows no reaction. That is number one. Number two, hydroxyl ion that we can see here show no reaction with blue litmus paper, but it tends to change the color of red litmus paper into blue. Altogether. Now, I said earlier on that this hydrogen ion has no effect on red litmus paper, but it turns blue litmus paper into red, while hydrozonium ion has no reaction on blue litmus paper, but it turns red litmus paper into blue. Altogether, this to show that the presence there is hydrozonium ion in that solution. And note, if a substance changes from red to blue, as of this, I said OH does not have any effect on blue, but it changed red into what? Blue. It shows that that solution is a basic solution. And if it's turned a blue litmus paper into red, it shows that the solution is acidic in nature. There is presence of hydrogen ion or hydrozonium ion in that solution. Altogether. Now, in essence for gases, as you also know that when I was explaining this, it is easier for us to test for aqueous solution. Aqueous solution. Why? Because aqueous solution already they are going to ionize. Altogether. But when we are talking about gases, in this experiment, we are going to be looking at gases. Many gases are insoluble in water. When we are dealing with solubility, I need you to understand that what gases are insoluble in water. Therefore, it will be difficult for us to determine it. Now, but we can easily determine if that gas is acidic or the gas is alkaline in nature. Altogether, the only means of using a litmus paper to determine if a gas is acidic or alkaline in nature is to make sure that that litmus paper is wet, or let me say it is moist. So a moist litmus paper can only be used to test if a gas is acidic or it is what? Basic. Hope we are together. But note that when you take a dry litmus paper, it will never react. Why? Why is it that a moist litmus paper can only be used to test for a gas? Why a dry litmus paper can be used to test for aqueous solution? Like for example, the aqueous solution of sodium hydroxide or sodium chloride, aqueous solution of sodium chloride can be tested using a dry litmus paper, while gases can only require a moist litmus paper. Why is it like that? It is because all gases will only dissolve in water to show the effect of hydrogen ion or hydrozonium ion. Altogether, when gases dissolve in water, they tend to become aqueous. Altogether, whereby, let's say, examples of all these gases are listed above, which I'm going to be telling you, if you see this kind of color, you should understand that there is a presence of any of these three gases there. Now, take a look at this. We have SO2 gases, SO2 gas, HCl gas, and NO2, which is a nitrate, hydrogen chloride gas, and sulfur oxide gas. Altogether, now, majorly sulfur oxide, hydrogen chloride gas, and nitrogen gas, nitrate gas, all turn moist blue litmus paper. Please note, they turn only moist blue litmus paper into red. Now, if they are turning moist blue litmus paper into red, it's simply trying to tell us that what these gases are acidic. Also to know that this SO2 and NO2 are otherwise known as acid anhydride. Acid anhydride. That means a substance that dissolves in water to produce acidic solution. Altogether, now if they turn moist blue litmus paper into red, there is a presence of SO2 gas in that solution, or hydrogen chloride gas, or NO2 gas in that solution. Altogether, let me take a look at this. Let me show you something in the reaction. In the reaction above, we can have this. If SO2 reacts with water, it is going to form, it's a reversible reaction, whereby H2SO4 or SO3 can be produced, H2SO3 will produce, whereby when this thing further ionizes, it's going to form 2 hydrogen ion plus SO3 2 minus, which are the ions that will be produced, whereby hydrogen ion will be produced. It is this presence of this hydrogen ion that makes sure that what this reaction, this gases here, does not have any effect on the red litmus paper. So we can only test, when you use the red litmus paper to test for this gas, it will show no effect. But if a blue litmus paper is used to test for this gas, it automatically changes the moist blue litmus paper into red. Altogether, or if I make use of HCl, or I make use of NO2, any of the gas. The second example I'm going to be giving you here today is this gas. Normally, this gas has a what? Irritating smell, something like a rotten egg smell. This H2S, hydrogen sulfide gas. And hydrogen sulfide gas is a weakly acidic gas. Altogether, whereby when it reacts with a moist litmus paper, it produces a weak acid. Do you grab? Now, we can only detect this gas because this gas is going to turn a blue litmus paper, please note, a moist blue litmus paper into a pale red. It's not going to produce a deep red, it's going to give us what? A pale red, something like a claret red. So it's going to produce a pale red to show the presence of this H2S. Altogether, hydrogen sulfide gas. The third example is carbon dioxide. As you have to know, when we get to identification of all these substances using a chemical reagent, I'll be explaining this, but I just need to explain to you, whenever you are using litmus paper in an experiment in your chemistry, altogether, note that they want you to test for gases, not ions. They want to test if there is gas present in that solution or not, and what kind of gas will be present in that solution. You can only test them by their color. I'll be showing you how to test them by their color, and you can test them by their reaction with litmus paper. So please note, if they are turning this moist blue litmus paper to red, you can easily write out that SO2, HCl, and NO2 are present in that substance. Are you getting me? SO2, NO2, and HCl are present. Now, under this thing that is there is not CO2. You see, normally, when CO2 gas, CO2, when it reacts with water, it tends to produce a weakly acidic, an extremely weakly acidic gas. Weakly what? Acidic solution. Whereby it's going to be producing H2CO3, which is even weaker than this H2SO3. Altogether, now, because of this weak acidic that is produced when it's ionized, it tends to ionize to give hydrogen and what? Carbon. But this gas, CO2, altogether has no effects on any of the litmus paper. That means if when you test the solution, your final solution, when you test that with a red litmus paper and it's showing you neutral, that means it's not showing any color. When I dip the red litmus paper into the solution, the litmus paper still remains red, or when I dip a blue litmus paper into it, it still remains blue. It shows that there is a presence of CO2 gas there. Altogether, another way that we can use to identify that is that it is a colorless gas, in form of a milky solution. Altogether, it has a milky color. We can use that to identify that, but I'll be showing you that later. But for now, I'm explaining it based on their reaction with litmus paper. So when that gas shows no reaction with litmus paper, automatically you should understand that that gas is CO2, because it is the only gas that will show any reaction with litmus paper, either blue or red. The next one is ammonia gas. You see, as you have to know that ammonia gas is the only alkaline gas that we have in chemistry. The only gas that is alkaline in nature is ammonia gas. Why do we say it is alkaline in nature? It is because when this gas dissolves in water, they tend to produce an alkaline solution. Altogether, it produces what? An alkaline solution. What do you mean? Now, this alkaline, so far it is alkaline, automatically this gas is going to convert red litmus gas that we have is chlorine gas. But there is a problem about this chlorine gas. You see, the only problem that is there is that whenever, to show that if chlorine is present in a substance, if the chlorine gas is present in a substance, you can easily identify chlorine gas away from a substance because of its bleaching property. You can use the bleaching property of chlorine to identify it away from a substance. Now note, whenever chlorine gas is reacted with a moist litmus paper, it can only react with a blue litmus paper. Altogether, so it converts a moist blue litmus paper into red and then bleaches it. Again, now why is it that chlorine gas will surely bleach it? Simply means it will bleach that litmus paper. Normally it converts to red. But when you later see the final product, it is going to become what? Totally bleached. Now, what does chlorine has that makes it bleaches the litmus paper? It is because of this reaction. Whenever chlorine gas reacted, don't forget I said that chlorine gas will react to the water inside the litmus paper. Now, when the chlorine gas reacted with the water in the litmus paper, it tends to produce two acids. Altogether, the first acid that we produce is hydrogen chloride, which is what hydrochloric acid we produce, and then the second one will not be what osochlorate acid. HOCl, osochlorate, we produce the acid. Now, this one is what a bleaching. The bleaching acid that is there is this HOCl. So it's going to produce these two acids, which is what HCl and HOCl. So that when this one further decompose, it's going to produce hydrogen ion plus osochlorate ion, which is the bleaching agent that is there. So when chlorine gas is now reacted with a blue litmus paper, it will form this solution here, whereby hydrogen chloride gas will produce, hydrochloric acid will produce, and then osochlorate acid will also be produced. But after some minutes, after some while, the osochlorate acid will be converted. It will convert the red litmus paper back into what? It is going to bleach the red litmus paper completely, so that it should not become neutral completely. Altogether, that is one of the effects of this chloride gas. So we can easily determine chlorine gas if it is present in a solution or not. If the final reaction of that litmus paper is being bleached to become neutral, then there is a presence of Cl2 gas in the solution. That is one thing about that. Now, in my next video, I'm going to be showing you how we cannot determine, based on if chemical reagent is added to the gas or not, how do we determine the cations and the anion. Please, if you are new to my channel, don't forget to subscribe to my channel and also click on the like button and notification bell to receive notification whenever I release a video. And please don't forget, try to drop a comment for me, either if it is only thanks, just to appreciate the good work so that we can move on together. Thank you.